Well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of July. Once again, I'm hosting this session, and for this month's session, we've got Ben Miller talking to us about what is the temporal table. And before I hand over to Ben, I do have a couple of slides for housekeeping that I do want to run through. First off, we do want to say a big thank you to our sponsors, Century One. Without them, it would be difficult for us to put these sessions on. So if you haven't already gone along to the Century One website, make sure that you do. They have some fantastic articles, videos, and downloads available for you to enhance your SQL Server or data platform career. For those of you who may or may not know, PASS Summit is quickly approaching us. Once again this year, it is in Seattle in the first week of November. If you haven't already registered and booked your tickets, you can use the code that we've got, or the two codes that we've got on this slide at the moment, and you can save $150 off of your purchase price. Now, before I quickly hand over to Ben, I do want to let you all know that this session is being recorded and will be made available on the DBA Fundamentals website later this week. And if you do have any questions throughout the session, don't hesitate to ask. I will be monitoring those and we'll get Ben to answer those for us. So with that, we'll hand over to Ben.
Great, thanks. So let's get started with the slides. This temporal table thing started in 2016, and there's been a lot of times I've been able to present this in conferences and in SQL Saturdays, and it always is a fascinating thing every time I go through it to see what people ask and the ways you can use these things. But I really love temporal tables for their built-in functionality. We're going to talk about some basic functionality. We don't really go too deep dive, but let's get started with this. This is the yay me slide, but the most important is the Twitter DBA duck. I'm really DBA duck everywhere. A lot of people ask me why, and so I'll just tell this group. When I was 8 years old, I learned how to talk like Donald Duck pretty well, and I still do it. Kids love it today, and so I became known as the Duck. So I became a DBA after I worked for Microsoft for a while, and so I just became DBA Duck. I have a website and Twitter handle and Facebook handle and LinkedIn handle, and so it's all DBA Duck everywhere, and YouTube as well. So plenty of DBA Duck out there. So if you need to contact me, please feel free to do so. And my email address, ben@benmiller.net, is my email. So let's get started with the temporal tables. Most of the stuff that you're going to learn is going to be seeing it in demo, so the slides are not going to be very exhaustive, but I will talk about some of the things that you will need to know to get things going well. The one thing that I won't go over in depth here it's in a different presentation, is the in-memory OLTP side of temporal tables. They've enhanced it in 2017. 2016 was fairly limited and didn't really work well. They didn't have a whole lot of hooks in there. But in 2017, they've made temporal tables a real thing in memory OLTP, but we're going to focus on 2016's functionality this time. So it is a 2016 feature. It exists in all editions, so they didn't cut it off for any specific edition like Express or Web. It's all in everything. It's a programming feature, so they let it be in every edition. The beautiful thing about temporal tables, if any of you have ever tried to keep track of changes that were made to a table and have had to write triggers and things like that, triggers are not needed here. It is built into the mechanism that we'll talk about. So that's a beauty. No extra plumbing needed. The plumbing's all part of the feature. A lot of questions that people have about their data, but the answers are really hard to get, like when did this change? What did it look like before the change? How many times has it changed? When was this row deleted? Things like that are pretty hard to get in a normal table. You really can't tell in a normal table without extra plumbing like triggers and stuff what the answers to those questions are. So I really like it for this. Temporal really stands for time-based, and they've really implemented this well. So when we see it, you'll understand why time-based things are pretty cool here. The other cool thing is there's no restore needed to get the data back. So if I deleted rows out of the table, I can actually get those rows back with all the values in the table. If I deleted 1,000 rows, I could get those 1,000 rows back because I know when they were deleted, and they were deleted in a transaction. So I no longer have to restore the database and pull back that table. So it's kind of nice there. Again, there's some overhead to it as far as data goes. So the more you delete and update, the more rows you get in your temporal table. But that's one of the cool things too. So what are temporal tables? Really, they stem from the classic problem of I need to know what changes. Really, this slide has a lot of verbosity to it, but the reality is I have a table. I want to know what changes have been made and when. That's really what that's all about. Having all of the changes happen is great. Auditing is not a feature here because it does not contain the user, but it does contain every data change, and it doesn't contain inserts, obviously, because inserts are still in the current table, so you won't see a record for that. But for every update, delete, you will see a row in the temporal table come down. They are called temporal tables by feature, but they are implemented with system versioning. So you'll see that when we go into the demo of how you enable a temporal table, and it is by turning system versioning on. So they didn't use the same vernacular in the feature as they did for the mechanism, but you still get the point. Each modification to the table is added, each modification to the table is added to a history table and dated with a start and end. You can think of those as effective dates. So this row was effective from this date to this date. And that's how you can tell time-based things. There are mechanisms they've given us in the select statement to go time-based, but that's really the crux of it, is there's a start date that it became effective, and then there's an end date where it went out of effectiveness and something else took its place. So if it was an update, the end date would be when I updated that row, and the previous date, the start date, would be when that row came to be. The cool part is that with this start and end date, you can actually reconstruct what the data looked like when the data was 2 days old, or when the data was 4 days ago, or 30 days ago, or whatever. However long you've had the system versioning on, you can go back in time as long as that temporal table has not been modified. The history table has not been modified or truncated or done anything with. You are allowed to do that. We'll talk about that in a little bit. So reasons for using. So there's a lot more reasons than these, but these are ones that I've heard over the time in consulting and in different jobs I've had. Of why I would use anything to help me with the time-based data that goes into my tables. So one of the first ones is auditing. People love auditing, especially today with new things with GDPR and all the other things that come with ISO certification, or even public companies in the US. We have SOC or SOX compliance because of Enron and those guys, where they had issues with what data was real. So auditing, huge. People love that. The only reason why I say auditing is not enabled here is because they have not decided to put a username of who changed the data or who deleted the data into the table. So that has to be done a different way if you choose to do this auditing, or you turn on auditing itself and start auditing things. But in a simple auditing format, that's what the data changes are. Reconstructing the state of the data at any given time you want. Past, obviously, anything past the time you enable it, you're not going to get that. But as far back as when you enabled that feature, you can reconstruct the data with these select statement where clause features, and I'll show you those in the demos. Calculating trends over time. How many deletes happen in this month? How many updates happen in this month? You can start profiling your data and finding out what is your model, or what is the behavior of this table? Is it highly updated? Is it highly inserted? Is it highly deleted? Or is it a mixture? That's one of the beautiful things I think about temporal history tables, is that you now have a way to tell when they were deleted, how many times they were deleted. If a row gets updated multiple times, it's a huge deal. Maintaining a slowly changing dimension. This is one of those throwbacks for the data warehouse people. A lot of times you may want to find out that the data had changed. Slowly changing dimension in a data warehouse is a really good example of dealing with data over time. You know exactly how many times that row changed, what the data was before, what the data was after. So that's another feature that was hybrid, and not just in the OLTP side, but in the OLAP side as well. And then recovering from accidental changes, which is one of my favorite features. A lot of times you get DBAs who may be under pressure to fix something, and they forget to do a begin tran, and they do a delete. They write the where clause, they highlight only the delete clause and forget the where clause. Been there, done that. I've got my Medal of Honor in doing that myself, and all of a sudden the data's gone. Or the classic one, I thought I was in dev and I'm in prod, and you need to get it back. So that's my favorite one, just because it saves me a restore, and it happens more often than some of the other things that you might do. So ways to enable. So there's 3 ways to enable history tables, and then there's a way, the 4th way is to add it to an existing table. So if you were to create a brand new table, the first 3 cover that. The first one is an anonymous history table, which means you're just going to enable system versioning. You don't care what happens behind the scenes. You just want it for emergency purposes. You're not really interested in what the name of the table is. You just get what Microsoft gives you. That's the first option. So all really you do is create a table with system versioning on, and Microsoft takes care of the rest. I'll show you what that looks like, but that's the first method. The second method is a default history table with a specified table name. So you can, when you create your table and want to enable it for system versioning, you can specify a table name and a schema. If you don't do that and you use the first method of anonymous history tables, the history table will exist in the same schema that the normal table exists in, because Microsoft creates that table. In the second one and the third one, you get to specify how that happens and why that happens. You can specify it in a different schema. You can specify it in the same schema, but you get to decide what the name of it is. Now the third one is the bells and whistles and knobs you get to turn. You get to decide what the table looks like. So there is a restriction that you need to have the columns that are in the table there, but you can create a custom table for purposes of using that. The reason why you do that is not to customize the schema, because the history table needs to match the schema of the normal table. But what the custom does is it lets you create that table first, put any indexes you want on it. You can clustered column store it. You can put indexes because you know you're going to query this way. You can do anything to that table before you marry it up with the normal table and create this thing yourself, and then marry it up with a statement. And we'll show you all of the demos of all of these 4. But the custom history table is most intriguing just because you do get to do some things. The thing I want to emphasize is when you enable temporal tables and you get this custom history table and you're like, oh yeah, once you enable system versioning on a table, that table is off limits from modifications. You cannot alter table anything on that table. The only thing you can do on that table while it's there is to rename it. So if you named it Bobby Tables in the beginning because of whatever, you actually can rename that table after it's system versioned on, because inside the table that keeps track of these history tables, it stores the object ID. So Microsoft doesn't really care what the name is. The name is for you, not them. So you can rename it afterwards and Microsoft will still let you do that. And that's the only operation you are allowed to do on a versioned table once it's enabled. Now the last one is, I think, more common in databases after people adopted 2016. Adding versioning to an existing table is probably more common today just because a lot of people were sitting on data. Not to say that people don't create new databases, but in the reality of our DBA world, we inherit more databases than we create typically. So adding versioning to existing table is the process of you creating a temporal table or not. The big change you need to do for this versioning to happen is you would actually add these columns that are the version tables. So the version of start date and end date, and then there's a custom period column that's really not a column, it's a clause that you would add to that table to say, here's my table, I'm going to add the start date and the end date, and I'm going to say that those start date end dates, they comprise the period that the system versioning needs to tell whether it's existing or not. Now the reason this is interesting is because you can marry this up with the second two. You can just specify a name of the temporal table, or you can create your own custom history table and add versioning to an existing table and marry them up after the fact. So you can mix and match those two, but there's good reason why you'd add versioning, and we're going to show you how to do that because, like I said, this is, I think, the most common one. Now, here's what happens when you do it. We're just going to go through all four of them, and then we're going to go show you a demo. So the anonymous history tables work like this. You create a table. When you create that table, you turn on system versioning by saying with system versioning on, and it will automatically create you a table called MSSQL underscore temporal history 4 underscore and the object ID of the system version table, the table that's being system versioned. So if my ID was 2 for the table, it would say 4 object ID 2, and actually it would hexadecimal it. So you get used to the. Oh, and actually this one I don't think has hexadecimals like the automatic naming of primary keys and stuff like that. This has actually the object ID. So I'll show you that feature. But it is created in the same schema you're in. So if you're in a history schema, or if you're in the DBA schema, it will create this temporal table in that same schema and name it like this name. We'll show you all of them so you can see it. And specifying the history table, this can be in a different schema. So if you wished to have your table created for you in a different schema, you could just specify that schema in the create statement, and it wouldn't have to be in the same one. And Microsoft would still auto create it so that you don't have to worry about what that looks like. But again, you don't really have any control over what that table looks like. Microsoft does it for you. And then in this way, it keeps the management simple for object names, so you don't have to worry about the MSSQL temporal history 4. You don't have to go find that table. The custom history table, you manually create the table first, and then you can create any indexes that you want on it before you version, and then you system version it on. This one, again, like I said, the two pieces that you have to add to an existing table are the start time, which is date time 2, and the end time, date time 2. And that becomes very important when you're creating these. You must provide a default constraint for the existing rows because you cannot, and these cannot be null. So that's the other thing I should have put ahead of time. But in the adding versioning to the existing table, these columns that you put on the existing table are not able to be null. They have to have a value. So in order to do that, you obviously have to put a default constraint. And I'll show you what the default constraint looks like for adding it to an existing table, because you need to have the dates in a way that is correct. So think about the start date would be either the beginning of time or it'd be today's date. The end date would be the end of time because they're still valid. And the only time they become invalid is when you delete or update them after you've done the system versioning on. And the other benefit to this guy with the clause that they've given us inside temporal table land is when you add them to an existing table, heaven forbid you have stored procedures or views where people say select star from the table. As soon as you modify that table and add these two columns, they become visible just like any other table, and they have start time and end time. If you don't want them to be seen or even affected by an insert into clause or an update statement or a select star statement, you can use the word hidden on those columns. I'll show you that in demo just so you can see how it's used. The caveat to the hidden word is that you can't use it anywhere else. This is the only place they've allowed this hidden word to be used, is in this context of adding to an existing. You can add the hidden keyword as well when you're creating the table. You can do that if you don't want them seen by default. But again, only in the temporal table context can you use this hidden word today. Whether they'll expand that, they've been asked to expand it, but the SQL team has not chosen to do anything more than just have this hidden keyword used for temporal table stuff. So end result, you get some automatic history without triggers. You get the data history for a lot of use cases we've talked about, and your solution is now realized to have your data temporalized. Now let's go in and show you the real deal of the thing, since this is a little talking things through is nice, but it's always nice to see the actual results. So let's go into our Management Studio. We're going to create a database for this purpose, so we can have let's see if I spelled it wrong. Create database, and there we go. Oh, I didn't have a go in between. I apologize. So, and you'll be able to get these scripts if you want them. I can send them to work, and we can deal with that. So the first one is anonymous tables, and this is as simple as it gets. You create a table, you put your schema here, you have and you can name these anything you want. So you don't have to name them sys start time and sys end time. You can name them whatever you want. I'd keep it simple. By default, if you don't specify datetime 2's precision, it is 7 precision, which is the largest datetime 2 you can have. It's 7 millisecond goes into the microsecond. So you don't have to specify here if you want. If you don't specify it is 7. You can specify a lesser, I believe. I think I did that in one of the demos, and it works fine. It just won't be as precise. Then these words must be used in your start, and these keywords always as row end must be used in your end time. Again, doesn't matter what these are named. You'll put these in the period declaration to say this column is my start time and this column is my end time. So I could put begin time and end time instead of sys whatever, but it's your choice. But then they have to not be null. They cannot be null. So that's why we'll show you the other thing. But this is the other keywords. This does not become a column. This actually is just part of the temporal table. So period for system time, and here's your begin and end time. And then after the table definition, you can add primary keys as well. So primary key here, you can add them down here in the constraint clause or whatever. And you can modify the normal table all you want afterwards. So you can add indexes later, you can do anything like that. It's a normal table. But this is the clause that turns it on with system versioning equals on as a clause. So this automatically creates a history table, and it is named MS SQL Temporal History 4. So let's create this guy, and it created it, and we'll go into our databases over here. We'll see demo temporal, and we'll see the tables, and you'll see that we have this new icon that looks like a little calendar with a clock in it. And this name is DBO department. Now Object Explorer will grab the temporal tables and marry them. So obviously I don't see the MS SQL history 4 table until I expand this table, and now I see my history. So you'll see that 901-578-250 is my history table. It says so in here. that it is the history table, and it is named as we specified, DBO, because my schema is DBO, MS SQL Temporal History 4, blah. So then I see my columns and I can see all of them. I did not specify hidden in this case. So if I did a select star, I would see them. We're going to go ahead and get, oh, look at that, interesting. It kept my same ID name. Now I'm not sure, that's not normal, but in this case, it's cute that I created a brand new database and that was the first object ID I got, and that's really cute. But we'll show you just select object ID just so you can see that it is actually that number, so that was correct. So now we're going to just look in systables, and systables will also have that ID. There's other properties down here that you can look at that show you temporal history type. So it's a history table, schema and data. So it will tell you in systables that it is a temporal table. Again, this originated in 2016, so these columns do not exist in 2014 and below, but it's kind of nice that they will tell you that here's all my temporal tables if I want to see them that way. So we're going to insert some data, and you'll notice that I have 4 department IDs, my names, and then 100, 200, 400, and 500. So we're going to insert those rows in there. And there's my 4 rows affected. Now and I'm going to keep this time and date. So we're going to grab the time and date here. The other thing I'll tell you is that the time and date are in UTC to keep anything away from your time zone deals. So they store the dates and times in UTC. That's why I get the sysUTC date time. You'll see when we query the table that it will also show that it was in UTC, but just know that's one of the things you'll have to get used to. So I'm going to update the department. I'm going to set the manager ID to 250, where the manager or department ID is 3. So I have 200, and the 400 will become 250. So we'll update that guy. And I'll get my sysUTC date time here just to keep the demo alive. And we'll go down and we'll select star from sys department, the DBO department. Now notice I have 100, 200, 250, and 500. And then my other columns, here's my sys start and end. So my sys start was 256 on all of them because that was one insert. So they became effective this date and time. My end time is 12/31 of 99/99 at 23:59:59 with 7 9s. So I am pretty end of time. I'm not going to live that long. So if that row becomes dead, I really don't care because I won't be here. And I can also select from this table. So let's take that ID off and let's put our ID back in. Since we got it here, let's grab that guy. And we'll go back into our, right here. And we'll just select from the temporal table. Now the temporal table is still readable. It's just not writable by you unless you turn system versioning off. So here's our only row. Notice we don't see 1 through 4. We only see the 3 because that's the department ID we updated. So here's our 3. The manager ID was 400. And it was effective, the start date, when it was inserted. So notice that's the same start time. And then it was ended at 2:56:53. So this is 0.5 seconds. It ended at 53 seconds. So that row is now time bound, that it was a valid row between this time, and that's what temporal does. So the options for querying temporal tables are a few. One, you can do an as of with a date time. Now remember, it is UTC, so just make sure you factor that in. The 2016 actually lets you convert your current time to a time zone. We'll show you in the end of this SQL statements. You'll see the how you convert time zones. But as of and a date and time, and it will just tell you what the data looks like as of that day. So it will insert these 3, and so we're going to show you this. Then there's a from, which is kind of like our between, right? From and to, between. It's all syntactical, so it just depends on how you want to do it. And then contained in. Now the caveat to these guys, and I should have put it in this list, but you'll want to go out to the website and the documentation and look at the greater than or equal to And we may do that in a second just to show you. There's a table on the documentation that says this from means greater than or equal to and less than or equal to, or greater than and less than or equal to. So it's not quite the same as between. Between does the inclusive of the endpoints, and the from, I believe, doesn't. We'll just make sure we can compare that. I should put it in here so I don't ever forget. And then the contained in also has its own greater than or equal to, less than or equal to constraints that it has. Now, all is an interesting thing. If you say for system time all, the system time all basically says, give me all the data. So you will see duplicates and what they were, and it depends on how you order them. So let's look at this one as of. So let's go grab the date that we put in the first place. This is our first date that we grabbed. So let's go put the as of to be there. And we're going to order by department ID. So here's my department for system time as of that date. And you'll see that my as of that date and time, it was 400. This is before I updated it. And notice my end time came back and said, but this row is not till the end of time. This guy actually changed later. So that's a clue to you. If you're going to interrogate these guys and you give a time and date, you will know that they've changed, because the sys end time will not be the end of time. So that's a clue to know that it's been done. So if I say system time as of, and I'll put the second date and time in there. So let's go get the second date and time. Here's a second date and time. We'll see what the data look like as of that date and time. 250, and this is the end of time. So you can also see that this row is 250, which is different, but it has the end of time. So it is the current row. That is the current valid version. If I do system time all, this is the weird one, because you end up getting 2 3s. And you see that I ordered by department ID. Now, if I could order by start time, or I could order by end time, or whatever I wanted to do, but just be careful, because this 400 was deleted, and it does show that it was deleted, and this one took its place. So 250 took its place. So again, all shows you more. Typically, when you do as of a date and time, you will only get one row for the keys that are valid, that were valid during that period of time. You won't get duplicates in those cases. The only time I've seen duplicates is when you use for system time all. And there are reasons to use that. I haven't ever used it myself, but you can certainly find reasons to do that. Now, the other caveat to tables is once you marry them up to system versioning, if I tried to drop the original table, it would not let me, because it says that it is not supported, and not supported operation on system version temporal table. So it does put a dependency that will not let you drop the original table. Some people think that it would be nice to drop the normal table and have the temporal table go away with it, but that's an awful lot of data loss if it was an accidental drop. So they do protect you from yourself. And you also cannot drop this other guy. So if I tried to drop this table, if I tried to drop that table, it also wouldn't let me do it, because it is participating in a system version temporal table. So you'll get the same error message, okay? So just know that it does protect you from blowing up the tables. Now, if I wanted to do something to this temporal table, this is something people go, well, yeah, you can just turn system versioning off. And yes, you can. So to change it, you alter table and set, instead of with, you set system versioning off, and it will unmarry those tables, and then it will let me delete that table or drop that table. So be careful. The reason why people will turn system versioning off is because they think that they need to add a column or to do something else to it. And that really becomes a pretty scary thing to do, because when you turn system versioning off, there is no mechanism inside SQL Server to say, well, let's queue up the changes while system versioning off, because I'm pretty sure he's going to turn it back on. That's not the case. So once you turn system versioning off, any changes within that time period before you set it back on are lost. You don't get the luxury of having those change. So just be careful of turning system versioning off without full control of that database so that you don't lose data when you go there. So let's alter the table and set it off here. And you'll notice I can drop this guy. Now, what I want to show you is in Management Studio is if I turn system versioning off on this guy and I said refresh, now it becomes a real table, right? It's not married up. You don't see the little icon that has the time-based thing, and it doesn't show up under here as a version table because it is not versioned anymore. So I am allowed to drop this table or drop this temporal history table now, and it's gone. Okay, I could turn it back on with setting it on, and it would resume. But again, every piece of data between will be gone or won't be kept. But now that's really interesting that Management Studio didn't pick that up. It now shows up here, but it also shows up here. So I guess there's a bug in 17.8.1 that it does not refresh out of itself when you've turned it off and back on. I will let them know that. That's great to always find them in demos when you do that. So we'll turn that off, and we will then go back here and see that now I have two, which is interesting. Oh, that's what it did. Okay, so never mind, it's not a bug. Here's what happened. So if I query this table, I forgot this is a feature. So here's your fun. This is the original table. This is the second table. So you are allowed to create a table and system version it off. And now this one doesn't say it's married up to that table. If I turn it on again, you will see that it creates another table, yet another table as a feature. You now see two tables down here and a new table here. And the reason it does that, so it does not assume, because I am an anonymous temp table, right? I am an anonymous guy because I did not say in this clause, I did not tell it anything about a table I want to use for my system version table. So it assumed that if there was a table named MS SQL Temporal History 4, this 901578250, it will not reuse it by default. I could tell it to. In the next one, I'll show you how you tell it to. But in this case, it won't assume, and it will create a brand new hexadecimal number after the fact to get you to your unique table name. That means that you will lose all your temporal history for the original one unless you turn it on and tell it you want to use this current table. So beware of that on the anonymous side. I don't recommend using anonymous temporal tables at all, because you just lose control. And when you set it back on, you get this other funky table, and then you have to do other funky things to combine them all. And it's pretty nasty. But one thing I didn't show you is that I can insert data and delete data in the versioned table while I am offline. So if I do this, actually, it doesn't matter. If I were to drop these guys, let's drop these guys and do the thing again just to show you. Drop this guy, and drop this guy because he's not, oh, he's still versioned, I think. Yes, he is. So let's set it off. And we'll drop this guy. Yep, so now we'll drop the department table. We'll drop this guy as well. And I'll go back up here. The key to remember is that I can create this guy, insert my data, do my update, and then go back and turn it back off. Let's go see if it created me the same ID. Nope, different ID. So I guess I better do that and find out that a new ID. We'll store that out here. All right, so if I select from this temporal history table, it does have that row like we saw before. If I were to turn versioning off, I could now truncate table and it would let me. So now I've lost my history. I didn't lose anything in my original table that has the start date and end date. I still have those. But again, everything that's in that current table is current. So the dates will be 9999 and the start date will be whenever it was inserted. So it doesn't touch the start date, but it allows me to do that. If I turn this back, I'll turn this on later. Actually, I got to delete it. So if I turn it off, I can truncate it, I can delete it, I can add rows, which I'm not sure why I'd do. I could add an index to it. I could then marry it back up with on. In the anonymous side, I would have to specify this table that I'll show you next to marry it back up to the same one. But again, very possible. So let's drop these tables. Okay, that's interesting. So the other thing Management Studio will do for you is if it is a version table, which it looks like it is not, that's really odd again. It is not, but it was. When I refreshed it, it went away because I turned it off. But if you don't refresh the Object Explorer and it has system versioned out here to the right, your right click will not show a delete item. You won't get that. Okay, so to delete these tables because we're going to recreate them in a different way. All right, so we've belabored that enough. The other ones will go fairly fast because we've talked about the options of turning things off and turning things back on and doing some modifications and stuff like that. So now I'm going to create me a schema called history. And I'm going to create me a department table again. I'm going to have my department ID. I have my system version on, or my system start and my system end, and then my period. So my system versioning on statement now adds me and says system versioning on, and in parentheses, this is weird syntax, so you're just gonna have to get used to this is how it works. System version on, and then in parentheses, not with commas or anything, history underscore table equals the name with schema qualified. So I can say dbo.department and history on my history table. So here goes my table here. And now if I refresh my tables over here, I will see department system versioned and I will see history.department. So all is well there. It still has the same columns as the other ones do, sysdate time, blah, 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 and my 4 columns there. So everything is happy. If I did systables here, you would see that I have a DBO and a history. They had the same name and department. Here's my object IDs. So no funky, weird MS SQL history table 4. Here's my create dates. It's a user table. The only difference would be is this history would have that flag come in here saying I'm a history table. Okay. Now this one will say this is the system version one. It's temporal type 2. So be aware that you can also find the ones that are system version and are the primary tables by temporal type equals 2. All right, so now if I turn this off, I can remarry it up with this history department. Now what we could have done in the previous example is we could have turned this on with history table equals and then that dbo.msql history, and it would reuse that table rather than having the table be just what it specified. So it wouldn't create that hexadecimal weird thing anymore if you wanted to do it that way. So that's one way to use that, is specifying your history table. So this is the default way that is probably the more common way to do it when you're creating tables, is doing it with a name. You don't create your schema, you just create the name and it will auto create it. So let's drop these guys. Now they're gone. Let's refresh this guy over here. They're gone. Now let's do this create user defined table. So the create user defined table looks like this. You create your department history table first. So I could have said history.department if I wanted to. And in this case, Notice how I'm creating my table, and my history table does not have the period like the other table did. So when I create my table for automatic, and this is my primary table, I specify a period column for system time. In my history table, it does not have a period. It just has a sys start and an end, and it has to be date time too, and it has to be not null. Okay, so this is an empty table that I create for my history. So let's create that guy. And now I want to create a clustered column store on this guy. So I create my column store. I create my non-clustered index on the period column. So sys end time is sys start time, and I include a department ID because that's how I might be querying this table. And again, querying the table, I could query it by where the sys end time or start time is blah. I don't have to use the as of system date. I can do my own where clause. It's just a table. So I don't have to use the as of system time unless I'm looking for a certain thing. After I've created my custom history table, which again, the requirement is it has to have the same columns as the current table. So here's my 4 columns, and it has to have the sys end, sys start with not nulls. Okay, that's the requirement. Outside of that, you can do whatever you want. The thing to remember is that if you add any other columns, which somebody says, well, yeah, I want to add a column. If you put any other columns, it will never get used in the history table because you're only going to get recorded the columns in the main table. So you could do that and do a null column, and it will just be null forever. And what a waste of space and time, but you could do it if you wanted to. When I create these guys, I still have to specify generated row start and row end. They have to be not null, so no difference there. Except in the system versioning, I specify an existing table instead of letting SQL Server create it. So here we go, create a little table here. The indexes are on it, so I'm all good. When it marries it up, I now look in here and I see my tables, my department history. In my department history, I see indexes. If I were to do it alone, I wouldn't have that. Those indexes, I'd have only what Microsoft gives me. And then I can turn them off and drop them. So let's turn them off and drop them. And then we'll go into the last one, which will take you through the creation or marrying up a table that you create, adding system versioning. So that's what we're going to do right now. We're going to create the schema of history. We're going to create our department table. Notice there's no temporal data in here yet at all. So I'm going to create my non-temporal table. And then I'm going to add me a primary key to my department table because that's a rule. You have to have a primary key on a temporal table. It won't be able to identify a row uniquely, so you have to have it. You can't do it without it. It will actually throw an error if you try to. And then I have my table, say I have data in it, whatever. I have an alter table. I add 2 columns, which is again, sys start time, sys end time. I must have generated always as row start and generated as row end. I can add the hidden flag, and I'll show you what that does to it. Add the hidden flag, and then I have to have defaults. And again, the default sys start is the current date and time in UTC, so you just default it to sys UTC date time. And then the default for the sys end time is the default for convert date time to 7 is what I did to convert this long stinker into the end of December and the end of the 9999 and then 235959 and 99. So that's the last date and time we'll ever see in our calendar system, which no one will ever live that long anyway that's alive today. So it's all good. And then I add the period for system time here and just define that. Once I add that to the data, I'll show you that if I try to, well, no, I won't show you because it says not null. Oh, that's the other thing. Notice it did not say not null here in my start time. That's because it's implied in your definition. So you can specify not null, but if you don't, it will make them not null anyway. So if I add these to my current table, it lets me do that. And then I turn it on and use this history.department table. Again, I didn't create it, so this isn't like a custom one. I actually allowed myself to have it create it for me. I just added all the plumbing to my main table. And once I turn versioning on with my history table to be history department, we'll show you what that looks like in Management Studio here. We get a department and we get a history department, and we see that we do get the columns that we want. And in our current table, we get the columns that we want as well. And notice how it did still put it as not null, even though I didn't specify it, because these words trigger it. Now, the interesting piece is if I did a select star from dbo.department, I would not see my two other columns because I did specify the hidden keyword. Okay, so it is allowed to put those on these two columns only. The combination of these words and the hidden are what takes the hidden and allows it to be done. So that would then give my current code the ability to not worry about, oh, there's extra columns. Now I could still see them if I specified select star, comma, sys start time and sys end time. Management Studio doesn't like it because I hid them. I put them as hidden, and so Management Studio is like having a IntelliSense nightmare because they are hidden, but they do exist and they would show up as date and time columns. So you do have to specify them if you want to see them. If you do hidden forever, you get any luxury. There's no and show hidden columns clause in the select statement, so you have to do that. So let's do this and get rid of these tables. And we will drop these columns, this database. So now I'm done, and let's do the last piece. So this is the other piece that you can do. So if you this is added in 2016 as well. So for time zone support, if you did want to mess around with time, because they are done in UTC, you can convert things from one to the other. So in SQL Server, they support a sys date time offset, which will tell me I'm a -4 hours in this VM, -4 hours from, that's my offset. If I do select star from sys time zone info, I will see lots of time zones. So these are the words that we'll use, and these are the current UTC offsets. I believe that this VM is in the Eastern time zone, I believe. That's why we're only -4 instead of -6. I'm not sure why that's doing that, but I guess I can adjust date time and show time zone is in Eastern time. So I'm -5, except we're in daylight savings, so we actually are -4 right now. So it does understand daylight savings time in the US and those kind of things. But this is the cool part of the SQL part of 2016 is now you can say sys date time offset at time zone of Central Standard Time, which again, these words are what you use. There are two, Mountain Standard Time, Mexico, and Mountain Standard Time, Central Standard Time. So that's we're going to Central America. We're going to do Central Time Zone. It should be 05. So if I do select at, it should be -5, and this is the time according to this clock. So this says 11:22, which is 23:22, and it minused an hour because I'm in Central. So it does understand how to do time zone math. So if you had your date and time in your time zone, you could say, what is my date time at time zone GMT Standard Time or AEST? You'd have to get the words, so that's why the sys time zone info exists, is so that you can get the exact words that you should use in here instead of GMT Standard Time. And you could actually find out what date and time. So in London, it is 4 in the morning, and it's +1. Because I'm in daylight savings, it knows what to do over there. So if I were to specify a date time and I at time zone it to Eastern, it would convert it. So now you have an at, and you can actually compound them. So if you wanted to say this date time at time zone Eastern, because that's the date and time today, and then tell me what it is in GMT, it would convert, then convert. So it's really kind of slick, but that gives you full run of how to mess with your temporal data. And that's why I wanted to show this. There really isn't, these are the only things you have to worry about is the text of the time zones to tell you what time zone you want to represent. And there's a little short demo that does that shows you the time zones as you go forward. But I just wanted to make you aware of the @ time zone clause. You can go look it up a little bit more and see all the permutations you can use it for. Again, you can compound it multiple times and it will just continue to morph your date and time out. You could select it out of the temporal table and say, I want to do @ time zone, and it does support variables. That's what this demo was for, is showing you that I could specify a variable and say Eastern time zone and then use that variable as well. So it's very programmatic to allow you to mess with temporal times. So that's the demo. Any questions that you have, please let me know. We have 5 more minutes before the end, and I'm happy to answer any questions.
Okay, so unfortunately, my questions pane has run away. I did put a thing out to everybody on the chat window. If you do have any questions, put them through on the chat window so that we can ask those. As Ben did say, we do have a couple of minutes left, so if you want to quickly throw those through, they're quite welcome. While we wait to give people time, as Ben mentioned, I will be able to add the scripts plus the slide deck up on the DBA Fundamentals archive site, and you will be able to come back and rewatch this session at any point in time from the DBA Fundamentals archive site later this week. So we'll just give it a couple more minutes, and then if there are any questions, we'll be able to continue. But while we do wait, I would like to thank Ben for his time talking to us about temporal tables. I would like to thank all of you attendees for being here as part of this month's session for the DBA Fundamentals Down Under. Okay, looks like we've got a quiet audience.
I guess I was really clear. Everything was everything made sense. It's great.
Fantastic session. Thank you very much, Ben. Thank you very much, everybody, for attending, and I look forward to seeing you all in a month's time in August. Thanks, everybody.
Hey, thanks.